Hi, you are welcome to this particular exercise we have for you. It is actually an exercise in which we are going to teach you how to draw something round in AutoCAD. Imagine something like the leg of a table, things like balusters, things like uh, newel caps, anything round you want to include in a piece of furniture. We have them for you in this particular exercise, in this particular tutorial, which we have taken time to work it out for you. To be very specific, we have drawn the leg of a table, the turned leg of a table, and it's an exercise that if you truly understand it, you'll be able to draw the balusters of a piece of furniture. You'll be able to draw the balusters of a staircase and things like that. We have also drawn something round like a plate, and it is an exercise that will guide you should in case you want to draw something round in AutoCAD. So remember to like and share the video. Also remember to subscribe to our channel so that when next another tutorial is out, you'll be the first to know. So let's get started. Yeah, we have to start by coming out with a rectangle, and we decompose it, which the rectangle will enable us to draw something like a grid or a guide for us to come out with the section, the vertical half section of the disc. There is no particular dimension, but all we just make sure that we come out with something that will guide us, to realize the vertical section of the disc or of the plate. If it is possible, just draw or just produce a grid to guide you come out with your templates. Now we are using the polyline to pick and then come out with something that looks like the half section of the plate. We close it so that we can have a plane figure that can easily be rotated into a solid. Now there is no particular method, but we just try to adjust it and convert some straight lines into arcs so that it actually looks like the plate or the disc or whatever form we want to realize. When you take the cursor to the center, it gives you 3 options. You choose where you can convert the line into an arc. We just try to adjust it to have a good shape. When you pick a summit and shift it, it goes easily, and that is the advantage of the polyline. Now let's take it away from the grid and then see if we can carry out some other adjustments. I see the need for us to adjust it. Now let's add something here like a small rectangle, so when we rotate we can then subtract it from the solid, so we can have something like a groove on the upper edge of our plate. I did not choose any particular dimension because the essence of the exercise is for us to know how to go about it and not the dimensions. Now I want that at these arrays there should be something round. I don't care about the dimensions too. You can come out with yours and choose maybe a particular radius or diameter of the circle. In this one we're going to unite to the table to the plate once it becomes a solid. What next? We're going to highlight everything, and we pick under the extrusion tool the revolution tool, and we identify our axis of rotation so that we'll come out with something round. We'll pick, and then we'll pick, and then we'll click to select an angle of rotation which is 360 degrees, and automatically our plate is realized. Do this for any other exercise, for any other round object you want to realize in AutoCAD. It is about the same procedure. Now that particular groove or that particular rectangular piece we pinned at the upper edge, you can see there it has come, and now when we subtract it, we are going to realize there's a groove on the upper edge of our disc. How do you do it? You pick the subtraction tool, click on the object, right click, and then you click on the groove on the piece that has to come out. Alright, congratulations, that is our disc which is already out. And if you are able to follow the exercises keenly, or this particular exercise very keenly, you realize that it is very easy, it is not difficult. Let's go to the next exercise, which is that of drawing the 10th leg of a table. We actually have to come also with come up with a rectangle, and we have to decompose it, and then we divide it into two equal parts. The essence is that such a leg is symmetrical. So we're going to realize, imagine that it is the section of the leg. We will realize one part of it, or one side of it, and then rotate. So decompose it so that we have it in pieces to enable us produce a grid, and the grid will enable us to come out with a template. Alright, now let's go back to measure and be very sure that if the width is 100 millimeters, the half of it should be 50. Our length is also measured to be very sure of what we are doing, because sometimes AutoCAD, or you give a command and the output, maybe it is not exactly what you really desired, so you might have to always measure it. Now we're going to step vertically this way, or any dimension. Let's choose in this case 20 millimeters. You can type on your command bar and then click on what you want to step. You right click, choose a particular stepping distance, and you click to have the various positions of what you actually want to come up with. Right, like I said in the first exercise, it might be necessary for you to really produce a complete grid, and then pick your polyline and carefully draw your template with the help of the grid. Alright, now let's have maybe something like at the center between. No, it has gone up too far, so let's choose something different, or let's say 250 millimeters, something like that, and see. Okay, at this level I think it is not too bad, so validate. Let's see. Alright, yes, we'll pick inside, because it might be necessary for us to also draw the polyline such that it enters into the width. As usual, we start with the polyline and try to see how half of it, because we need the half of it. So we start from the center to this external edge, and then every step or every junction of intersection of the lines, we might have to use them, or to have the different summits, because like in the first exercise we made sure that at some points we needed to convert some straight lines into arcs. It will be a similar thing in this particular exercise, and in other templates you will have to produce in future, perhaps for other exercises. So here we're going to right click and click on close. This enables us to come up with a closed object. When you click, you see that it is actually a closed object. It is highlighted all around, therefore it is a closed object. Now we're going to carefully see how we can realize our template. The template in this case will actually look like the half section or the half vertical section of the leg we want to produce. Half, because when we take a revolution of it, it is going to give us a 3D or a solid. So carefully, there's no particular dimension, there's no particular design. We are only being very careful to make sure that our leg should be like what we saw in the introduction. Yes, we convert. When you take your cursor to a summit, it gives you options. You don't need to click. You take your cursor carefully to one of the options and you click before you go on. Like here, there are 3 options. We're going to select convert to act. Click, then you adjust where the act. Sometimes it becomes very large, we don't know why, so you have to click and bring it closer to where you actually want it to be. Good, it is not too bad. Yeah, we'll keep adjusting. The essence here is to have the template. Yes, the same, something like this. I am very sure when you take your own exercise to do, it will be better than mine, because you must have mastered every step we are taking. Alright, something like this. Yes, it might have to come out a bit, a small curve, yes. Or here also we convert to an arc, or to that particular. Yes, okay, we are already coming out with something. I know as technicians you see that it is already something like half vertical section of what we wanted. We need to adjust the upper part. Let it be something strictly let's just adjust it. Okay, this one might have to come in a bit. We don't want to have a very fat leg. You adjust this also, let it look real, what can be realized on the left. When you bring this one in, you realize that the line at the bottom is not vertical. Okay, so click and pull it in to have it vertical. Good, but you may decide to allow it. It's still a choice. We keep adjusting until have something good. When you click, you just pull it to whatever direction we want it to be, because we're actually adjusting. This one needs an adjustment. Do I look at it? Just click. Good, something like this. Alright, now we are going to, as usual, under the extrusion tool, we click on the revolution tool. After highlighting what we want to rotate, we select the axis of rotation. Obviously it is a vertical axis, and we click and type 360, which gives us the complete revolution. And what do we have? We have a complete round leg of our table, of our balusters. of our chair or whatever. Did I say the leg of a baluster? No. It can be a baluster, it can be the leg of a table, it can be the leg of a side stool. Anything round follows the same procedure. Alright. Now that is it. Or maybe we'll just see how we can add or the rectangular upper portion of the leg. It might be necessary. So let's type 100 by 100 and then we'll extrude to a thickness of 100 millimeters. So it's something like a cube, 100 millimeters cube. We click on it, take the displacement 3D displacement tool, we locate the center of the solid, carry it to the center, the upper center of the leg we have just realized, or we have just drawn, and okay, the snapping options were on. So what do we have? Something like that. It might not be perfect, but something like that. You have to unite. You click on the uniting tool, then click on both solids you want to unite, and then you right click to have it now as a complete solid. Congratulations. And that is what we're able to come out with. Make sure this exercise you do it several times, so you can contact us on the various contacts you have on the screen, so that in case of anything, maybe you want to learn AutoCAD, we can always meet you. Thanks, and may God bless you.